Okay, 81. 81.
Yeah, I tweeted on this.
Okay, so page 81, we are looking at the sum of rational expressions. Sum means adding, rational is fractions. So again, we are adding, guys, listen up. Don't make the words stress you out. We are adding fractions. Now, we are adding rational expressions. So let's real quick just think about adding fractions. Now, if I add fractions together, just a quick refresher, if I add fractions together, and we're only going to worry about common denominators for right now in this class, for this unit. So if I have common denominators and I'm adding fractions, what do? You add the what? Numerator. Add the tops. 3 plus 2. 5 over 5. So think about what you're doing, which is just 1. But think about what you're doing. When you are adding fractions with common denominators, you add the numerators, you add the tops, and you keep the denominator the same. You know that from elementary school. We're going to use the same thought process when I'm adding expressions. So if I throw a variable in there, what's that going to look like? So, couple steps. So because when you add with the same denominator, you never add the denominator, back from middle school. So when you add two fractions with the common denominator, you don't do anything with the denominator, you keep the same. So step 1, so you add the numerators. You add the numerators together, and that's going to kind of be what we did with the lesson right before this, where we kind of combine things together. So you add the numerators. Step 2, keep the denominator. So it's the same process as when you have done fractions. You probably haven't done them for a little while, but it's the same process. If it's common denominators, you add the numerators, keep the denominator, and then simplify if you need to. You may not need to simplify, but we'll look at a couple and see what it looks like. Simplify, maybe, depending on what it looks like. Okay? So the process is the same as a normal fraction, except I'm just throwing in variables. Okay, let's look at one like this. This is the only part we're doing on this, so on this page. So if I have 3m plus 6 over 8m plus 4 plus 5m plus 2 over 8m plus 4. So get over the fact that these look a little stressful. These look a little complicated. I get that. But if you think about it, we are adding rational expressions. We are adding we are adding two fractions that have variables and stuff in them. So we are adding rational expressions.
Wait, so it's going to be 8n plus...
Well, we have a common denominator. So what we're going to do in this unit, just for this unit, is we are going to have common denominators. My denominators are the same. So if you go back to middle school, when you add fractions, if you already have common denominators, you just add the what? Numerators. So if I add the numerators, we are just going to combine like terms like we did the previous section, the note page right before this. You just combine like things in the numerator. What things can I put together in the numerator? 3m and 5m, which is 8m. 6 plus 2, 8. So you have 8m over 8. Your denominator stays the same, 8m plus 4.
Is that simplified?
Do it? No, because you can't reduce with the plus there. As I go any questions on what I did so far? Common denominators, you add the numerators together, keep the denominator the same. Now see if you can simplify this. So let's factor. So now once you add the things, simplify, factor like we just did on the first part. So what can I factor out of 8m plus 8? 8. So I'm going to take an 8 out and I get m plus 1. Guys. Take an 8 out, so you have an m plus 1 left. What can I factor out of the bottom? 4. So I have an m plus 1 left. So this is like what we spent some time yesterday talking about. Factor the top and bottom. Now it's not going to ask for excluded values, so you don't have to do excluded values.
Would it be 4m? Yeah, it'd be 2m.
Yeah, sorry. There you go. My bad. Okay, 2m plus 1 was a test. You guys passed. Good job. Now, it's not going to ask for the excluded value, so you don't have to put what m cannot equal. Just reduce it. How can I reduce this one more step?
Make it
2 over 1. Just distributing will get me back to where we were. So just reduce your number. 8 over 4, which is a 2. 8 divided by 4 is 2. That stays on top. So 2 times m plus 1 over 2m plus 1. I cannot cancel out the m plus 1 parts because it has that 2 here in the bottom. So they're not exactly the same. And that's your answer.
How is it?
Yeah, they're not the same binomial. You can only cancel out when they're being multiplied, so you have to take the whole m plus 1. Now, you could distribute the 2 back through if you want to, but you don't necessarily need to. So what we're adding is adding the numerators together and then simplifying like we did. Let's do another one. Okay, thanks. Let's look at one like this. Like what? Well, I'm looking.
Hey, calm down. Let's get to the homework.
Okay. I'm all about the homework. M plus 3 over 6m cubed plus 30m squared plus 6m over 6m cubed plus 30m squared. Again, get over the fact that some of these look stressful. I get it. There's lots of stuff going on. However, the denominators will be the same for what we're going to do today. My denominators are the same. I have common denominators, so I just add my numerators together. So if I add my numerators, what things combine on the top? Yep, 6m and m. So 7m plus 3 we are adding, so it's just 6 and the 1, 6 plus 1, not m squared, because that would be multiplying. Over, the denominator stays the same, 6m cubed plus 30m squared. You keep the denominator the same, and then let's see if we can simplify. Can I factor 7m plus 3? No, so it stays 7m plus 3. Can I factor anything out of the denominator? 6m squared, which will leave me m plus 5. Does anything cancel? No. So that's the answer. So sometimes you'll factor and things won't cancel, and you just leave it the way it is. Nope, it does not ask for excluded values, so you do not have to do excluded values. Okay, let's look at one more. Ooh. Let's look at one like...
Is this all only going to be on this page today?
Yep, no, this is the only section on this page. Let's look at this one. If I have n minus 2 over 6n minus 12 plus 5n minus 1 over 6n minus 12. Like I said, with what we're doing today, you will have common denominators. So even though they look complicated, your denominators should always be the same. Common denominators, so I'm going to add my numerators. If I add my numerators together, I'm going to get a what? 6n minus 3. So don't make this harder. This is why we practice like the distributing and stuff. Even though we're not necessarily distributing, we'll do that tomorrow. We're still kind of combining like terms on top. So 6n minus 3 over 6n minus 12. Make sure, like we did previously, to factor to make sure nothing simplifies. What can I factor on the numerator? So I'm left with, just saying numbers. If I take out a 3, I have a 2n minus 1. If I look down here, I have a 6n minus 12. 6 out. So I'm left with a n minus 2. So it would be, my binomials don't cancel, but look at your numbers. 3 over 6 reduces to 1 over 2, 1/2. So 1 over 2, and then the binomials are the same. So 2n minus 1 and n minus 2. Now you could FOIL out if you're distribute through if you want to, but okay. So on the homework, that is 31 through 40. Now some on the answer key have FOILed out, just so you know. It might look a little different, but or distributed out. Okay, so 31 through 40 on that one. We're only doing 2 lessons.